Any one of you can confirm it in the chat box. Okay, so let's move on to the first question of today's step 4, International Justice Day. In honor of International Justice Day, the Supreme Court of Chefland has decided to address all pending cases simultaneously. For a given case, the accused will be convicted if the convincing power of the prosecution denoted by the integer x is greater than or equal to the convincing power of the defense denoted by integer y. Determine whether the accused is convicted. So this question is very simple. All we have to do is find if x is greater than or equal to y, and we can print if it is yes or no. I hope this question is pretty clear and it was pretty much easy. Voice is not clear. My voice is not clear, is it? Is my voice audible now? Yeah, okay. So let's move on to so the first question is clear, right? So we will be moving on to the next question. Maximum point. Chef and Shafina are playing a series of n games. Each game has a winner. For the ith game, the loser is to the 2 to the power I points to the winner. Find the maximum number of points Chef can get if he wins exactly X games. Okay. So this question is very much easy as well. What we are doing to find the maximum number of points, we will allocate the X number of games from the last. Okay. Right. For example, if we have if we have total game 4 and 1 will be the game in which Chef will win, so we will allocate this chance of game is the game which will be won by Chef. So he will be earning 2 to the power 4 points, and he will be losing 2 to the power 1, 2 to the power 2, and 2 to the power 3 total coins, which is equivalent to 16 E1 minus 8 plus 2 plus 4 plus 8, 12. 14. So we will be left with 2 points. So this is the implementation. I have done the same exact thing in my implementation. From 0 to n minus x, I have calculated the coins which he will be giving. And then for the x games, I have calculated the coin which he will be earning. And then I am outputting the total coin which he will be left with. I hope this solution is also clear. Is there any doubt? Okay, so if no one has any doubt, we will move to the next question. Next question will be taken by Sandeep.
Okay, we will discuss the third question. So basically, third question says you are given a two strings S and T. You need to transform S into T, basically converting S into T by following this operation. Choose any indexes I and Y distinct and swap them. So if we want to convert S into T, let's work out on the sample test cases. Okay. So if we want to transform, like we will uh, do with test with every case. Okay. So just as given is n is greater than 2, n is greater than equal to 2. So we will first try for n equal to 2. For n equal to 2, there will be several possibilities. Okay, s can be 0 0 and t can be 1 1, or s can be 1 1 and 0 0. If the number of zeros into my s string and number of ones into my t string is not equal, then we can't make s into t. Is this part clear? If the number of zeros and number of ones is not equal in s and t, so then we can't change s into t. Okay, this is clear. Is this part clear? Okay. So just count the number of zeros into s and count the number of zeros into t. If both are not equal, then we can't change s into t. So and this is part is clear. Then now we will move on. If the zeros number of zeros and number of ones equal into the s and t, then how many number of swappings we need? So how many number of swappings we need? It depends on how many bits are differing. Like if you are given a string as 0 1 0 1 0 and 1 0 1 0 1 0, then consider this. You need to uh, transform these all zeros. Wait. Hmm. So we need to change this zero and this one. We need to swap this zero, this one. We need to swap this zero, this one, and this zero and this one. So we need to three swappings in this test case. How we can find out? We can find, like, if my bits are differing by pairing. If the number of zeros and number of ones are equal, then if the 0 and 1 in the SI and ST is not equal, then we will definitely swap them. So we will count the number of differing indexes, matlab where the indexes are differing. We will count them. So we will count si is not equal to st and count plus plus. So here I am initializing the count equal to 0, and then si is not equal to sit. We will count plus plus. Just in this test case, 1 and 0, 0 and 1. So here the two indexes, there will be si and st is not equal. So we need to swap for each of the two indexes. We need to one swap. So I will divide the count by 2. Uh, let's consider this test case. Here is the one differing at the first index and one differ in the third test case. So we will swap the first and third test case into the test case 4. Okay. So how we will matlab, basically we will find out how many swapping we need. Let's consider if n equal to 3, then what we can do. If n equal to 3, then we just need n equal to 3. Let's consider this test case. Here we need to one swap, then the first index and second index, and third will be the same. So just we will need one swapping. And if the k is given more than 1, let's consider k is equal to 1. So we can change s into t by the swapping of first index and second index. If k is given 2, then we will swap 1 and 1 first, then no change in the s, and then for k when the for the second swapping we will swap first and second index. For the k equal to 2, we will swap I equal to 2 and I equal to 3. Then second swapping we will for swap will I equal to 1 and I equal to 2. If k is given 3, then we will perform this operation 2 times, and lastly we will perform the one time this operation. So just we need to do this operation 1. So for each of the greater, when the n is greater than 2, just k should be greater than number of needed swappings. Okay, how many needed of swapping? Just the if the k is greater than from that, then we can output yes. If that is not greater, then we can output no. We just have to consider only the n equal to 2 as our test case, which will be we will write all the test cases for the n equal to 2. N equal to 2. I will write down the all possible test cases: 0 1, 0 1, 0 0. So for these test cases, k can be anything. If the k can be anything, we can change as into t because both are the same. So k can be anything. We will change into s into t. For these test cases, we need a one swap on the index 1 and 2. On the index 1 and 2, we need a one swap. So k should be, what will be the k? K should be odd or even. Hello, am I audible? Hello. for that k should be odd, because for in the one swap we will change s into t, then um, in the one swap s will and t will same, then after the we will left even times of k, even k. So we can change s into t. Okay, but if this is the test case, if this will be the test case, then k should be even, because this and this is same, s and t is already same. So just k should be even, then we will swap even times. Like in the first operation we will change I equal to, we will swap I equal to 1 to 1 and 2, and then the second I equal to 1 and 2. So s will equal to t. There will no change if the k is even. So just in the implementation, I have done this. If the number of zeros and one are not equal, then see out no. Then I considered how many swapping we need, and just applying on the n equal to 2 for explained every for the every test, every possibility of s and t. I have generated test cases 0 0 and 1 1. Just see out yes, don't check, don't need to check for k. And if 0 1 and 1 0, then I told you k should be even. So when the k should be even, then see out yes, or k will be odd, then see out no. Or if the our third possibility, if this is the this is the possible case, then k should be even. Then k should be even. So when we will output yes, and odd we will output not. And in the other for the any n greater than 2, for the any n for greater than 2, if the k is greater than from our cnt was number of swapping we need. So if the k is greater than from cnt, then we will output yes, otherwise no. So this part is clear. Did you guys understand this? You can ask your doubts about this question. cnt is basically number of swappings we need. CNT is basically number of swappings we need. Basically, the SI is not equal to TI, then we need to perform a one swapping. If just consider here, then I and 0, so the at the first index this is not equal, and the third index we not equal, so we need to swap them. So CNT is basically number of swapping we need. Okay, and other doubts?
अब शुक्ला भी आ रहा है, मजा आएगा. डिपेंड बनी नहीं है.
If the n is greater than 2, then we will if n is greater than 2, then we will perform the operation like that. If in 101 and 110 is the given, then we will, if k is greater than from 1, because we need only one swap, and if k is greater than from 1, then we will perform the swapping into first index and third index. Okay, we will perform an operation with the first index and third index for k greater than 1 when the for k minus 1 times. Okay, and in the last one operation we will perform swapping between second and third index. Okay, for the k minus 1 times we will swap first and third index, and for the first, in the last operation we will swap the second and third index. Okay, now any doubt? Okay, I will explain the third question. Okay. Okay. So in this question, the question asks what is the minimum integer c such that there exists an array satisfying this condition. A should be less than c and not distinct in integer x and y where x divides the y or ax is not equal to y. Okay. So first, consider for first index. So if x is equal to 1, then it will divide every index because 1 divide. Okay, it will divide every index. Okay, 1 divide every each of the number. So if I consider at the first index the number 1, then remaining places I can't take 1. Okay, if x is equal to 2 and I fill the number 2 on the second position, then for the fourth position I can't take 2, and I can't take 4. I can't take 1 because 1 and 2 divides 4. So I need to increment my number. So I will take on the fourth index I will fill number 3. Similarly for eighth index will divisible by 4, 2 and 1, both of the 3. So I can't take 1, 2 and 3. I can't take these numbers. I need to increment my number by 4. At the position of 1, 2, 4 and 8, we need to increment our number. In this between, we can reuse these numbers. Okay, the basic observation here is the minimum number to divide y will be 2. Then basically y will be twice of x, 2x. Y will be twice of x. So for the each of the value of x, we need increment the number for yth index. So value of c, the minimum value we can generate an array will be log of n plus 1. Like if give n is equal to 1, then just we will output 1, and if n equals to 2, then 1 divides 2, so we need output 1 and 2. For n equal to 3, for the first index we will take 1, for the second index we will take 2. We can take 2 for the third index also, because 2 is not divided 2 will not divide 3, 2 will divide 4. Minimum index will be the 4 where we need to increment. If n is given 4, then we need to increment because 2 divides 4, so we need to increment at the fourth index. For n equal to 5, we don't need to increment any number because 5 is not divisible by 2, 3 and 4 also. And for 6, can we take 3? Yes, we can take 3 because At the 6 is divisible by 3 and 2, and 3 and 2 value having 2, so we can value take as a 3. For the n equal to 7, can we take 3? Yeah, we can take 3 because 7 is only divisible by 1. For n equal to 8, can we take 3? Now, because 8 is divisible by 4, 2 and 1, both of 3. 1 will also divide 8, 2 will also divide 8, 4 will also divide 8. So we need to increment our number. Okay, so this array will satisfy these conditions. So here is my code. I take the vector of answer n plus 1, and for the value of c, log 2 1 plus 1, this will be the maximum value we need to generate an array of n size, and I will output the maximum value. When we will increment our number, when it is the exact power of 2. At the first we increment our number, basically we increment our number here and here, and at the fourth index, then eighth index. So when the my set bits, basically built-in pop count is a inbuilt function which will give the number of set bits into the binary representation of any number. So the set bits are equal to 1, then we will increment our value. Okay, so I will run my code and you can see the output. For the 3, it will give 1 1 2 2, and for the 8, it will give you answers like that, and for 9 and so on. For the 16, it will continue the 4 4 4 up to 15 and value 5 for the 16. Okay, have you it out? Yes, you can apply this method also. Like, just we need to satisfy this condition which is given key x will not divide. uh, when the x divide y, then ax should not be equal to ay. Okay, I consider it good. Okay, okay. It is also accepted, maybe. Okay. TCS. What is the time complexity of my code? Time complexity is basically order of n. I will run my loop from 1 to n, and this function gives you in the order of 1 time. Built-in pop count is basically function which gives you number of set bits into the binary representation of any number. So this is the order of 1 function. This will give you an order of 1. Okay. Maybe I will tell you one fun fact how you can check the number is the exact power of 2 or not. Maybe you know, if any number is given which is exact power of 2, just you need to do a simple thing. You just decrement the number by 1, then this will looks like this, and take and between this number and this number. So basically x and x minus 1. If equal to 0, then number will be, this is the order of 1 kind of function, then this will be give you the exact number is exact power of 2 or not. Okay, maybe this you was already know or don't know. So this is the fun fact for the finding the exact power of 2 or not. Any doubts? in this question and fourth question. If you're having any doubts regarding third and fourth, okay, I will check your code. Okay, I understand. I understand what you have done. So basically, he has done for the first time, like he initialized index 1 as a 1, then index 2 as a 2, then index 3 as a 2, then multiple of 2, he will initialize by the increment by 2, by basically 3, and for the 3, he will increment the multiple of 3. So 4, 5 will also 2, and 6 will increment by 3. So this kind of error will be your answer. Am I correct? Yeah, I understand your approach. It should be correct. It should be correct. Yeah, minimum divisor basically multiply minimum divisor basically like if 2 divides that number, then you will increment that, and 3 divides, then that kind of thing. Okay, I will check in.
No, actually, my approach is like I'm taking the index of the number, assuming one based indexing,
Hmm.
and in that thing, I have actually written a function which calculates the maximum divisor of that function of that number other than that number. For example, if I have the number 12, then the maximum divisor would be 12, but I'm not considering 12, so my maximum divisor would be 6.
Yeah.
So the value at index 12 would be at in one bit indexing, the value at index 12 would be 6. So I'm making that kind of array. Like for each number, for each index, I am just putting the value of the maximum divisor after that number.
Yes, yes, yes. So this is the same approach kind of like my approach, because I am considering the minimum and divisor minimum number which will be of y is 2x. The multiple of x, the 2x will be the first maximum divisor. Okay, for the y 2x will be there. Then I will be incremental on. Your approach will be also correct. I understand your approach. It should be correct. But the time complexity of your approach is little bit more than order of n, because you are running the loop of order of n and the finding and the divisor, which will be the kind of n log n time complexity.
Yes.
Hmm. So you can find in the also order of n time complexity, which I have explained here. If the number is exact power of 2, then you will increment your value and you can derive it out like this. Okay.
Yeah, fine. But how did you observe this thing in the question, right?
Basically, the observation is which I explained already. Like for the value of y, for the value of minimum value of y, uh, it will be the 2x. Then
Like, how did you observe that it is 2x for the minimum value of y? Like the idea.
here is a given x divides y. So the first will be the first. What is the first number will divide the x? Then the basically 2x. The 2x is the number which is divisible by x, the minimum number. So I need to increment only that point. Okay, for the given particular range, just consider a range, any range. Just consider a range for like 9, 10, 11, 12, 13, 14. 15. In this range, any matlab, any of the number will not divide the any number in this given range, because minimum number is 9 and the 2x basically 18. 18 will becoming late here, so I need to increment number only at the position of 18. Okay, this part is clear. If I am provided the value 1 for the 9, then I can provide the value 1 for each of the number till the 17. Okay, then I will increment my value for 18, because in this between no number will be divided the each of the any number. Okay, so that was the idea.
Yeah, got it.
Yeah, okay, okay. So root hour of n, so your time complexity was the n root n. If you are facing any doubts in regarding the code forces contest, then you can ask into the group code which you ask. You wanted to discuss the code forces contest also, which you are talking about into the group.
Yes, I was able to solve like two problems in that. So if you can explain the third one.
You like the previous one, which was like based on I think bits, right? It was
Sorry?
like I think it was based on bits, right? That question, right?
Yeah.
Okay, one second. Let me just quickly check it once. I think I've solved it. Just a second. Okay, so basically, what you have to observe is that if when we take a bitwise OR, the particular bit will always be set. Just a second. That whenever you like pick a sequence which and like take a bitwise OR, if even one of the bit is like set, your that bit you cannot like unset. For example, if you take let's say, let me check. I'll 1 second, just a second. Is my screen visible? Then I'll just like quickly solve it.
Yes.
Okay. So basically, what we have to do is when we are taking like a bitwise OR. So in a bitwise OR, if we have something like 0, 1 and we take a bitwise OR of something like 0 or 1, 0, 0, let's take something like this. The bitwise OR of like this whole thing is will be 1, 0, 1, right? That makes sense. So
Yes.
what? Yeah. So what we have been asked is that for like a particular n, as far as I remember, for a particular n, we have to like make a sequence which is always increasing. and like the bitwise OR of each like consecutive term is equal to your n, I think, right? So what you can observe from this particular question, I'll share my code quickly, is if you have this, for example, if since we have been like provided with the constraint, I'll just say this. So if you have one, what will happen? If you have one, you can always only generate one. Okay. But if you have something like three, so what is the possible sequence? One, two, three, right? Like they have provided it to us in the test case. We can like write the bit representation of this. What will you get from this? One, like let it be one something like this. Then you have 0, 1, 0. If you take the bitwise OR, just a second. Yeah, just a second. So if what you will observe is that if this particular bit is set, you just have to find like the smallest number that you can get, which will complete this, right? So how can you find the smallest number? You will take this one and subtract the number that gave you this bit representation. Okay, so for example, like where is it? Yeah, here if you see, what I've checked is if my number like this representation just sees if this particular bit at this particular index is set or not. Okay, so for example, for 3, what will be the binary representation? 0, 1, 1, right? So I'll run a loop and I'll find that this bit is set. So I'll be like, okay. I'll check this bit is set. It will be okay. And this bit is not set. So I'm like, fine, okay, done. Now I have to generate a sequence, right? So what I'll do is whenever I find a set bit, like if this particular value, like n minus basically 2 to the power I, whenever this was set, if like I need two pairs, right, for this to be complete. So I'll check if like n minus 2 to the power I is greater than 0. And if it is true, I'll add these two to my answer, like 2 to the power I and n minus 2 to the power I. Okay. And what about this part? And then if you like, if this part is set, then I can do the same with the others. Whenever I find a set bit, I'll like add these two pairs and I'll get my answer. From the code, you can see this. I've taken all the bits that are set using this particular property. Then I'll just iterate it through all the bits. If I find like a power of 2 which satisfies this constraint, I'll push it back into my answer and then I'll just reverse it. And n should always be the last element. Okay. Like this is the last element that should be in your list according to the question. Just
Yeah.
so yeah, it's just like an observation, and you should like see if these particular conditions are true. Just have to like make sure that you have like a complement in it. Okay, is that part clear? I think.
Yes, yes, that's clear.
Okay, sure. So like that was the logic. You can try it again when like submitting it, and if you face any issues, you can ask in the group.
And can I ask one another question? Actually, I was solving a CSCS problem, and I
Okay.
have the code and the solution with me.